Here we have a SAT math question. Okay, let's go with the information. There is a figure given over here. In the xy plane above, the area of triangle OPQ is 3. What is the value of K? So using the area of this triangle OPQ, that is 3, we have to find the value of K. So since we have the area of the triangle OPQ, let me get the height and base of the triangle. So the height is given by the line segment that I have drawn over here. So the length of this line segment is the y coordinate of the point P, that is K. So because since the y coordinate of the point over here is K, so we'll have K and the y-axis over here. So the length of this line segment, that is the height of the triangle, is K. And OQ represents the base of the triangle. The length of the base of the triangle is given by the exponent of the point Q, that is K positive 1. So K positive 1 is the length of the line segment OQ, that is the base of the triangle. Okay, we have the area of the triangle OPQ, so that is 3. Okay, now instead of area of triangle OPQ, we can use a formula to find area of a triangle, that is 1/2 times base times height. So the base of the triangle is K positive 1 and the height of the triangle is K, so equals to 3. Okay, now we have to solve for K in this equation. So now first let me get up the denominator 2 over here. For that I multiply both sides by 2. When I do so, this 2 will cancel out. So 1 times this stuff is the same, that is K positive 1 times K equals to 3 times 2 is 6. Okay, now let's distribute this K to this one and this one. When I do so, I'm getting K square positive K equals to 6. Okay, here I have a quadratic equation in K, but it's not in standard form. Standard form means we have to make the right side 0. To make the right side 0, I have to subtract 6 from both sides. When I do so, this 6 and negative 6 will cancel out. I'm getting K square positive K negative 6 equals to 0. Okay, now we have a quadratic equation in standard form. Okay, I think this quadratic equation can be solved by factoring. For that, we have to multiply this constant term by the coefficient of K square. So when I multiply this negative 6 by the coefficient of K square 1, still I'm getting negative 6. I have to get two factors for this negative 6, so that the sum of the two factors equals to the coefficient of K, that is positive 1. So I think positive 3, negative 2 will work. So because when I multiply positive 3 and negative 2, I'm getting negative 6. When I add them, it is equal to positive 1, which is the coefficient of K. So to get the two values of K for this quadratic equation, I have to change the sign of each of these two factors. When I change this positive sign, I'm getting negative 3. Then K equals to the second, to get the second value of K, I have to change the sign of this factor. If I change this negative sign, I'm getting positive 2. Okay, I got two values for K. One is K equals to negative 3 and the other one is K equals to positive 2. Actually, K is the height of the triangle. Height of the triangle can now be a negative value. So we can reject negative 3, the value negative 3 for K. We can accept the positive 2 for K. So therefore, the value of K is 2. We find 2 in option A. The correct answer choice for this question is option A.